Okay, my friends, so let's suppose you took a look at our data down here and you said, you know what, Sean, I don't think it's bell-shaped enough. I don't trust the average. Well, that's totally fine. What statisticians have come up with is another alternate way to test outlier method number 2, which is data that are too far away from typical. And that one ignores the average and the standard deviation completely and focuses only on quartiles. In particular, it focuses on Q1 and Q3. Let's head over to the board and take a look at how it works.
Okay, my friends, so I brought Q1 and Q3 in from the Excel calculator. So Q1 is 445. That means 25% of the countries have scores less than 445 points, and 25% have scores more than 517 points. So the middle 50% of the scores on these tests are between these two. Now, in order to use this next method of data points that are too far away from typical, it relies historically on this thing called the interquartile range, which is shorthanded by IQR. And you may have noticed that in the Excel calculator. All it really is it's the distance between Q3 and Q1. Now, the Excel calculator calls it 72.5. I'm going to round it to 73, just because I'm rounding all these things up to the nearest whole number so I can try to do some mental math a little bit easier. So that's the distance between these two. It's how far apart these two things are. Now, this method's going to seem a little bit weird, because what it does is it sets up the low and the high, just like we did with the average and the standard deviation. But the way it sets it up is a little bit strange. The low starts with Q1, and the high starts with Q3. And then we build ranges off of those two things. So Q1, we're going to start at Q1 and subtract, and this is where it gets kind of goofy, 1.5 times the IQR. Why 1.5? It's a damn good question. I've been looking for why 1.5 for years, and I can't find a decent rationale for it. If I get some more time in between making all these videos, I'm going to take another deep dive back. I haven't looked for a few years. But 1.5 seems to be the standard value for how many interquartile ranges below Q1. Q3 does the same thing, except it adds 1.5 IQRs to Q3. So if we're going to look at this visually in a second when we go back to the computer. If you start at Q1 and Q3, you then build ranges up and down. And if you're thinking box and whisker plots, we're going to come back to that in a second too, because that's a really good way of visualizing these things. So all we've got to do now is run the math. I'm out of room, so let me clear the board, and then we'll actually run the math on these things. Okay, we're back. All I did was I took the low and high formulas, I'll draw a line between them, and I plugged in the values that we had for Q1 and the IQR and things like that. And I saved the subtraction and the addition. We'll put Sean on the spot, see if he can do it in his head. So for the low cutoff, this is going to be in meaning exactly the same as it was for the standard deviation one. We're putting a fence on the low end. Anything below that fence is too small to be typical. So how low is that? Well, if we do 445 minus 109, let's see if Sean can do this. 15 minus 9 is going to be a 6. Got to carry that 1. Becomes a 3. 3 minus 0 is 3. 4 minus 1 is 3. Okay, so any test score below 336 is going to be exceptionally low. And I don't think there is one, right? No. Our lowest score was 388 at Morocco. So that means there are no low outliers because they're not far enough down. We'll visualize this in a second. Promise. Promise, promise, promise. Okay. High outliers. How about the high outliers? Okay. So the high outliers, we start with Q3, which was the 517, right? Yep, 517. And then we're going to add 1.5 times the 73 again, which is the 109. So let's figure out what that's going to be. 7 plus 9 is 16. Carry the 1. 1 plus 1 is 2. 1 plus 5 is 6. 626. And no, the max score we had was 616. So nothing is larger than 626. So by this definition of outlier, I'll call this outlier definition 2B. And I'm just going to write it in the little box on top of me there because trying to say those formulas out loud without tripping over my own tongue is going to be next to impossible. We don't have any outliers. Now, if that bugs you, please don't be bugged by this. unlike probability, which is a more natural mathematics, statistics is completely human-made. We've invented these statistics. Somebody decided that 1.5 times the IQR is the one to use. If we brought the 1.5 in tighter, then some of the data points would fall outside. So why 1.5? Again, I don't have a super satisfactory answer. I've never been able to track down why 1.5 is used. But it's okay that the two different outlier methods give two slightly different results. Nobody says they have to be the same. I know it's hard to get used to. Some of you are used to math classes where x equals 2 or x equals 4. Statistics doesn't have that kind of universal agreement. It's ways of measuring nuance. Let's take a look at what these ranges look like on our data and then also look at a box and whisker plot, since this is all based on quartiles.
Okay, friends, so here we're back in the Excel calculator, and I'm going to go ahead and I'm going to wander over to my extraordinarily manky box plot generator that I told you about before. We're going to line up the axes so it matches ours. So we're going to format the axis so that it starts at 350 and ends up at 650. I am really, oh, look at that, it read my mind. I'm really looking forward to when I can actually integrate all this together. I have no idea how to do it right now in Excel. And like I said, I'm pumped to actually figure it out. But for right now, anyway, it gives us a nice visual. All right, I'll slide it down. I'm actually going to turn the axis off so we don't have to look at it. So we just see the box plot floating above. All right. Now, it's a little bit tricky to see based on how the histogram has grouped the data. But that min value of 388 is that little spot right there. And then the max value of the 616 is this guy floating over here. Remember that the bars, even though they look like they're going past the ends of the box and whiskers, that's just because the histogram groups the data. For example, 388 is between 370 and 390. We lose that specificity of it being exactly 388. Also, the same thing on the other end. The 616 is above 610, but less than 630. Now, let's add left and right bounds that we calculated on the board to the graph and see what happens. So if we put the 336 to the left, where it should be on the scale, and the 626 to the right, you can see that all of the data in the box plot is contained between those two values. That tells us that there are no outliers in the data. And here's another way of looking at it. One of the things, and this is when I miss being in class with you all, one of the ways I've always liked to visualize that 1.5 IQR is by building it graphically by looking at that box plot. So check this out. Here is the width of the interquartile range, represented as this yellow box right here on top. I'm going to move this up now. There we go. Now, if I take that and increase it by 50%, it becomes 1.5 IQRs. If I then stack that under Q1, you can see that that range goes farther than my smallest data point. That means my smallest data point is not too far to the left to be considered an outlier. We can repeat this process by stacking that 1.5 IQR on top of Q3. And once again, the largest data point does not fall to the right of that range, which tells us that my largest data point is not far enough away to be considered an outlier. And again, remember, the 1.5 is not a magic number. I did a little more digging after I recorded the last video. John Tukey, who was the guy that I put in the video, said apparently this is the guy that decided upon it. When he was asked why 1.5 should be used, his answer, which I thought was hilarious, was, well, 1's too small and 2's too big, so use 1.5. And I just thought that was cute. That was very, very cute and somewhat arbitrary, obviously. We'll talk more about that when we start talking about bell-shaped data later. But I wanted to give you this visual about what the 1.5 looks like when you compare it to a box plot. And again, if you want to, you can always get in here and goof around with number of bars. It's not going to change anything except how the data is broken up. So anyway, like I said, just wanted to give you a visual as to what that 1.5 IQRs looks like.